Hello, boys and girls. Today we are going to review a bunch of shape names. We're going to start with our triangles. And the important thing to remember when looking at an acute triangle and an obtuse triangle is remembering what that vocabulary means. There are three types of angles. We have right angles, which are 90-degree angles that have like the square corner. We have acute angles, which are less than 90 degrees, so anything that's smaller than the right triangle. And whenever I say acute, I like to pretend like I'm really cute and say acute. And then the difference between that and the obtuse angles are greater than 90 degrees. So anything that would be bigger than a right angle. And for obtuse, I like to, because it's a big angle, I like to have a really deep voice and pretend like I'm some huge monster and say obtuse. So you have the acute angle and the obtuse angle. And I have a lot of fun saying that. So with an acute triangle, and we have here, it has three acute angles. All of them are acute. And with the obtuse triangle, it has to have one obtuse angle, and in here this is your obtuse angle. So next we have the three triangles that are the hardest to remember. An equilateral triangle, this one, because it has the word equal in it, is a little easier to remember. All of the sides are congruent. They are all the same size. So if this is 1 inch, this is 1 inch, and this is 1 inch, they are congruent. They are all the same. An isosceles triangle, shown next, has at least two congruent sides. So as you can see here, my side and my side are congruent, but the bottom is much smaller, so there's a different side length. Now a scalene triangle, all of the sides have different lengths. So they're all represented as having different lengths. Alright, now I know you've remembered this, parallelograms. The important thing when dealing with a parallelogram is to understand what the word parallel means. Parallel lines will travel in the same direction forever and ever if they kept going, and they would never touch if they were to keep going forever and ever. So these would just continue to go off of the page and would never run into each other. And so in a parallelogram, you have a four-sided figure with two sets of parallel lines. So in the figure shown here, that I tried my best to draw, these two lines, or this one set of lines, is parallel, and this set of lines or pair of lines is parallel as well. Now with a rectangle, you also will have parallel lines. But the important thing to remember with a rectangle is that it has four right angles. Notice in our parallelogram up here, these angles were not right angles. Some of them are acute and others are obtuse. But with my rectangle here, all four of my angles are right angles, which I can use that to show. It will have two sets of congruent sides. So here I have my top and my bottom that are congruent, and then my sides are congruent, which is why we can see the really long, skinny rectangles. And that's how you first learn to identify a rectangle. Next, a square is also a four-sided figure with four right angles. Oh, wrong button. With four right angles. But in a square, all of the sides are congruent, meaning that they are the same size. So that is very important with a square. Now, if we think back to the definition of a rectangle had the four right angles, and it said that it had to have two sets of congruent sides. So let's think about our square. And does that have the same definition? So the only difference in the definition is the word all here. In a square, all of the sides have to be congruent, but in a rectangle, we have 4 right angles, 2 sets of congruent sides. But how about this? I'm drawing what we typically say is a square, but it has 4 right angles, and it has the top congruent with the bottom, and the side congruent with the other side. So technically, a square can be a rectangle, but a rectangle is not always a square. Because we see here, this rectangle is not a square because all of the sides are not congruent. So a rhombus I like to put on the same page. I put it on the same page as a square because they are very similar, just as a square and a rectangle are similar. So a rhombus is similar to a square because it's a 4-sided figure. It has to have parallel sides, and they all, once again, they all have to be congruent. The only difference here is that it does not need the 4 right angles. So you can kind of think of it like a square that's been kind of stepped on and smushed to where all of the sides are still congruent. They still have parallel lines here and here, but they do not need to have right angles. So it's like a square that all the sides are congruent, but no right angles needed. Next, we're going to get into trapezoids. There are 2 types of trapezoids. The isosceles trapezoid, which we see first, and that is a 4-sided figure that has at least 2 congruent sides and 1 set of parallel lines. So let's go ahead and find these in our shape. Let's look for the 2 congruent sides. Point to the congruent sides. If you said that those were the congruent sides, you are right. Those are the same size. And then next I want you to look for the 1 set of parallel sides. If you said these were parallel, you were correct. Now a right trapezoid, notice it has the word right in it because we're looking for a right angle. Here's our right angle, and we also will have 1 set of parallel sides, and so in this case, parallel sides. Okay. The other sides are not parallel because if this side kept going forever and ever, it would eventually cross right about here. So those lines are not parallel. All right, moving on to some fancier words. Polygon. Polygon, all it is a closed plane figure with sides made from straight line segments. So a triangle would be a polygon because it's closed, meaning it's not open. Let me do a non-example over here. If I started to draw a triangle but left it open, I like to think that somebody could be inside and they could get their way out. Okay? That would be an open figure. Our polygons need to be closed figures. So everything from a triangle to a square to a rectangle, as long as it has straight sides and that it is closed, then it's a polygon. So another non-example over here, a circle is not made up of straight line segments. It would not be a horseshoe sort of shape because that would be open and it wouldn't be straight. We could have something crazy like this, but once again it is open and something could get out. We could have a crazy one on an example of a polygon as long as these lines are straight, and if it's closed, then technically it's a polygon. A quadrilateral is a polygon with 4 sides. So we've already seen a bunch of quadrilaterals in our definitions that we've gone over. We have squares, 4 sides, rectangles, 4 sides, parallelograms and rhombuses have 4 sides, trapezoids have 4 sides. So all of those shapes are quadrilaterals because they all have 4 sides. Now a kite is also a quadrilateral, but the important thing to remember with a kite is that the adjacent sides, these are the ones that touch, that they will be the same size. So if I tried to make my, oh, that's not the same size, there we go. And then thinking like a kite, you're going to have a longer bottom there. So these adjacent sides are the same size, and these adjacent sides are the same size. Last but not least, several different polygons that you really just need to remember the number because they can look in different ways. A pentagon will have 5 sides. A hexagon has 6 sides. An octagon has 8 sides. And a decagon has 10 sides. And so really with those, it's just memorizing the number that goes with the word. All right, we will practice these shapes in class. I hope you guys have a great day. See you next time.